faz parte de uma série de...
Good morning, everybody. Welcome to our 38th Global Online Seminar in Biodiversity Informatics. This series has been ongoing for several years, although it's been, shall we say, more irregular this year because we've been teaching the online course on ecological niche modeling. So we have a bit of a break from the niche modeling course with a special seminar. I heard from two sources that Alan Veiga from the University of São Paulo in Brazil had a very interesting talk to give about fitness for use of data. And I think that's a very crucial dimension to this field. So it seemed like a very good idea to invite him to do kind of a special seminar. Again, we've kind of suspended the series during this course, which ends on Friday. So this is a special seminar. But Alan is working as a postdoc with a good friend and colleague of mine, Antonio Saraiva, at USP at the University of São Paulo. So I'm, for several reasons, quite excited to hear this seminar. So Alan, I'll turn this over to you, and then at the end of your seminar, I'll come back and pass on to you any questions. And to the public, to those who are watching, please send your questions as they come to you so that we have questions waiting for Alan. Okay, Alan, all yours.
Thank you very much. Thank you for the invitation. Let me share the screen. Can you see my screen?
Yes, it's fine.
Okay.
Perfect.
Okay. So today I will talk about data quality according to the fitness for use perspective. Before I start, I would like to highlight that my background is in computer engineering, and this work was based on computer science and computer engineering research. So if you come from a bioscience background, don't be bored with my simple examples in the area of biodiversity informatics or bioscience. I just want to illustrate the concepts on data quality using simple examples in the biodiversity field. But I encourage you to try to contextualize this concept on your context, on your use case, on your challenge. Okay? Well, I organized this presentation in 3 parts. First part, we want to understand what means data quality using some principles and definitions in the literature. Then I will talk some about the challenge about data quality in the biodiversity informatics. And then I will present a conceptual framework that was designed to try to support the biodiversity informatics in this field, in the data quality issues. Okay, so let's start with the first part. The idea here is to understand what is data quality according to the literature. But before I go in the definitions of data quality, I want to give some introduction and start with the definition of information. Well, information from the Greek is morph plus eidos. That means form plus idea, concept, proposition. So information denotates to give form to the essence of something, okay? And so we can say that information is a representation of the reality. And this reality could be a fact, an event, or something in the real world, okay? But this representation of the reality is different from the reality itself. Okay, there is a gap between the reality and the representation of the reality, the real world and the information that represent this real world. The good news is that this gap can be measured according to some attributes that we call data quality dimensions. So I can measure the completeness of information in relation to the real world, the consistency or the precision of the information according to the real world. So to give an example of this representation of the reality and this gap, let's say I want to represent my real location right now. I could do this using as a latitude and longitude as information, as this representation of my current location. I could give this latitude and longitude that represents my location, but there is an error, there is an imprecision in this in this information, this latitude and longitude, this coordinate, right? And if I want to improve this precision, if I want to minimize the gap between this information and my current location, I could improve this, putting more decimals in the latitude and longitude. So I would have a better representation of the reality according to the precision perspective or resolution perspective, right? Of course, this latitude could be completed wrong, but has a better precision. In this dimension, it's better. And if I want a perfect location, representation of the reality with no error, with no 1 millimeters of errors, I would have something like this. I would need a precision, infinite precision, to have the exactly point where I'm located, to represent exactly my real location. Okay, so that's a example how the information represented this gap between the information and the real world. So we can say that smaller this gap, better the quality. Okay. So this takes us to the first definition of data quality. This is one definition in the literature that say that has quality if the information interpreted from the data is able to represent the real world. So let's say we have some facts, some event here in the real world. We digitize this, we represent this fact in data, for example, a spreadsheet that describes this fact. And when we get this data and interpret this, and we try to extract some information of this, for example, I get that number and that number represents a coordinate. Then we have the information. If this information represents well the real world, so this information have quality. Okay, so this is one definition. Let's test this definition using this example. We have, let's say we have this real world. This is a wolf, and we want to represent this real world in a record. And this record have a name, and I put as name this scientific name that is the correct scientific name of this species. Okay, so this record represents the reality. I would say yes, because this is the scientific name, correct scientific name of this wolf. But let's say we have another representation. This is another record and representing the same reality, but the name is maned wolf. So this second record represents the reality. I think too represents well too, because this is actually a wolf. But would you say these two records have the same quality? No, right? Because the first record has a better precision, and wolf could be other species. So this definition is not very precise, not very created, because depends in some case the definition, the meaning of data quality. So let's see another definition. This definition say that data have quality if it is compliant with a set of requirements. Okay, so let's say we have this requirement: taxonomy must be supplied at species level in the taxon rank. Okay, so we have this record 1, and the taxon name is this, and taxon rank is genus. Does this record have good quality? If we consider this requirement and consider the definition of data quality as data must be compliant to requirement, we would say this record is not don't have good quality, right? Because it don't meet this requirement. But let's say the same data, the same record, does this record have good quality for being used in a study about wolf distribution in South America? I would say yes, because with this information, I know this is a wolf, so I could use this information, right? So depending on how I use the information, I could have, this data could have quality or don't have quality. So this is another definition that is more general and I think is more suitable. That say data quality, the quality of data is determined by their fitness for use. Okay, so some data may have quality for some purpose, but maybe for another purpose this doesn't have quality. Okay, so we always assess the quality of data according to the data purpose, the context of use this data. Never we can say this data is good or not good without considering the context. Okay, this is based on a principle that data quality is an idiosyncratic concept. That means it's peculiar to an individual or to a context. So define what is data quality is as hard as to define what is beautiful or what is good or what is valuable, for example. So what is good for me maybe is not good for you. What's good for me now maybe is not good for me later. So for someone in somewhere in some time, something can be beautiful, good, valuable, or has quality or not. Okay. So determining data quality depends on the context. If I change the someone, if I change the sometime, if I change the somewhere, the data may have quality or not. Okay. So this is the definition of data quality that we're gonna use. Data fitness for use. So to define what means data quality, I must have the use, the context that the data will be used. In this context, I gonna use some types of data depending of the use. So the input of the use case changes according to the context. And for each of this type of data, I have different data quality needs depending the use case, depending the context, right? So this is the definition of data quality that we're gonna use, right? So let's see some what's the challenge in the biodiversity informatics concerning data quality. Well, today we have this scenario. We have a lot of data providers around the world, and thanks to some standards, we are able, and protocols, we are able to put all of this data together, aggregated in aggregators such Global Biodiversity Information Facility, GBIF, and other aggregators, national aggregators. So this is very useful because we have a lot of data available to use for a myriad of uses. The problem is, as this data come from different sources, in the aggregator, we may have very good data mixed with data that's not so good. And when a data user get this data, retrieve this data to use for some purpose, for some use, he always have to ask if those data are fit for use for him, for this context, right? And to answer this question nowadays is not very, very easy. So how can we answer this question for this user? First thing we have to do is to understand what means data quality for this use case, okay? So we have to define what is data fit for use for this user. What are the data quality needs? What means data quality for this user? Once we have this, we have to implement some data quality solutions, some methods, some tools, some software to meet these data quality needs, to meet these data quality requirements. Okay, so these solutions will operate on the data and generate a data quality report. This data quality report generate the status of quality of some data according to the data quality needs provided by data user. Okay, so this data quality report say this data set has this quality according to your needs. Then, with this data quality report, data user are able to make a data quality assessment and data quality management of this data. Okay. Also, this data quality report can be used by the data providers to make the data quality management, improve the quality of the data on the source. So, but what I mean with data quality assessment? Data quality assessment is, basically is to judge the status of quality in a specific use case. Okay, so let's say we have a data user that will use some data to create a national species checklist. And for this context, this data is suitable. It's okay. But let's say we have another use case, another context, that is generate species niche modeling. The same data maybe is not fit for this use. So when data user assess if some data, judge if some data have quality for him or not, this is what we call data quality assessment, okay? But if we don't have quality, what we can do, that is the data quality management, is the improvement of data quality. So this is basically try to improve the status of quality of some data. And we can do this using two different approaches. The first one is the data quality control. This happens in this way. Let's say we have a data digitizer. He inputs his data in a data set. And in this data set, we have good data mixed with not good data. And we have a data quality control mechanism, a software that try always to improve this data set, but it not assure that all this data will be suitable. fit for use, okay? But it always try to improve the quality of this data. Another approach to improve the quality is a data quality assurance approach. And this approach can be performed in also two ways. One way would be the data digitizer try to input his data, but data quality assurance mechanism ignore or reject those data that is not fit for use. Okay, so in this data set, we'll only have data that are fit for use. Another way is have a data set that may have data that are not fit for use, but when the data user try to retrieve some data from this data set, a data quality assurance mechanism select only a subset of data that are fit for use for him. So data user only can see that those data that are fit for use for him. Okay, so this is another approach for data quality assurance. So to enable data quality management and data quality assessment in this scenario, we need these three main components. We need to understand what our data quality needs. We need some solution that implements tools, mechanisms to meet those data quality needs. And we need data quality reports for data user understand the status of quality of those data. Okay, so think on this. We designed a conceptual framework to describe those components. Okay, this conceptual framework was proposed in the context of here in University of São Paulo, in the context of TDWG, Biodiversity Information Standards, this in a interest group on biodiversity data quality. And it had support from GIBF and from Museum of Comparative Zoology of Harvard University. So this conceptual framework, as a PhD thesis in computer engineering, it was a very complex framework because it has a mathematical base mathematical formalization of all the concepts. So if you get the thesis, you will see a lot of formulas. It has 8 fundamental concepts plus 21 derived concepts. But because this was necessary to detail all the components, all the concepts regarding the fitness for use in the biodiversity informatics, but it can be simplified. We can generalize this concept and see in an overview way, and that was we did in this paper that was published in PLOS ONE, and where we try to show the conceptual framework in an overview in a more light way. And that's I want to show here. I want to show this conceptual framework in a more practical way, okay? So let's see. So this conceptual framework can be organized in 3 main parts. The first one is the data quality profile that describe the data quality needs in a given context. Okay, so this profile basically describes a use case, the context where I want to describe the data quality needs. It describes the information that is valuable. This is information elements that are valuable in this use case. And we have three more parts that describe what means data quality of each of these information elements in this context. Okay, so if you remember our definition of data quality, basically this defines what is data fitness for use, right? When we have defined this, we have to implement and describe some methods and mechanisms to implement this, to generate results based on this data quality profile. And these solutions will generate a data quality report saying how good is the quality of this data based on the data quality profile. So let's see in details how to define a data quality profile. Well, the first thing we have to define is the context. And the context can be whatever you want. Let's say you are writing a paper about a study of distribution modeling of a specific species in a specific area. So this is your use case. This is your context. And you will need some data quality criteria. You will have to measure the quality of the data that you will use in this context. Okay. But this use case could be more general. It could be, for example, what means data quality in the agrobiodiversity area? Or what means data quality for my institution, for the Museum of Comparative Zoology? So I can define what means data quality for this more general context. Okay. So once I define for why I need quality, for why I need the data, the second step is to define what kind of information elements I'm gonna use or is valuable in this context. Okay, so let's say in my use case, I need some location, I need a taxon name, and I need a time, an hour of an event. Okay, so those would be my valuable information element. But just choose these information elements is not enough. We have to define what the meaning of each of these information elements. So for example, how could I describe my location? Could be a point, or could be a point plus an area of error, or could be with a quadrant, or could be with a spot, an area field, and or could be, depending of the use case, for example, for marine stud, the depth is very important, or the height may be important. So what means the location in the use case? Okay, so this is important to define too. So when I have the context, the information that I'm gonna need in the context, I have to define how I will measure the quality of each of these information. So what means, how can I measure the quality of coordinate, for example? That would be an information element available in my context. So to measure it, we use those data quality dimensions that I mentioned before. There, in the literature, we have a lot of data quality dimensions, different definitions. There is no consensus of which are the data quality dimensions should be used, or the definition of them. Okay, here in the sites of TDWG, we have some dimensions that we used, and some definition with some examples. But this is the way that I measure the quality. So coordinates, completeness, consistency of taxonomy, or the resolution of the date, for example. Okay, and I can measure this dimension using numerical values, numerical variables. For example, the resolution of taxonomy in a data set goes from 0 to 100. Or the consistency of event date of a single record could be binary, has consistent or not, don't have consistency. Or, for example, the completeness of coordinates of single record could be a categorical. It's complete, partial complete, or not complete, okay? So just to give an example, let's say we have this definition of completeness of coordinates, where I say coordinate is complete if values for latitude, longitude, geodetic datum, and uncertainty in meter are supplied. So I will measure as complete if it's in this complied with this criterion. Or coordinate is partial complete if values for latitude and longitude are supplied. And coordinate is not complete if values for latitude or longitude is not supplied. Okay, so this is a way that I can measure the completeness of coordinates. And in this case, I have this data that only latitude and longitude are supplied. So I would have a partial complete coordinates, and I can use this to measure my entire data set. But partial complete is good or not good for my case. Let's say I have accuracy of scientific name equals 3. This is good or not good? So to determine this, we have to define some criterions saying how good the quality should be for those data be fit for my use. That is made in this part where what we call data quality validation policy. So in this part, let's say we have P, all possible values of data. Okay, so P is all possible values of data. And we have a subset of possible value data that we call Q that have quality, that has quality, that is good for use. And the complement of this are those possible values of the data that doesn't have quality. So the data quality validation policy made this separation of data, what is good from what is not good for use. So let's say in the use case A, okay, in the specific context, I would say that coordinate must be complete or partial complete for being used, okay? But in a different use case, let's say in use case B, I would have that coordinate must be complete to be fit for use. Okay, so you may have the same measure, but with different criteria depending on your use case. And the final part of the data quality profile is the improvement policy. How can I improve the measure of the quality to make data more suitable according to this criteria? So basically this improvement say, how can I improve the quality of the data according to my dimensions? Let's say if I want to improve the coordinates completeness, okay? This record is not complete because only data that is supplied is the verbatim locality. But I have this enhancement that say recommending coordinate values based on the verbatim locality. If I have a mechanism that do this improvement, I would have something like this. I have all the field supplied, of course, with not good precision. The uncertainty in meters is not very good, but In the dimension of completeness, I have now a data that have a complete coordinate. So, data quality profile has described what we have to do to measure the quality, to say how good this quality should be, and how to improve the quality for data be suitable for use in this context. Now we have to describe what kind of solution we use to generate a report based on this data quality profile. So in this data quality solution, we have to describe basically two things: the method that I'm gonna use and the mechanism, the implementation of this method that we're gonna use to generate the report. Method is very important because depending the method that I use, I may have different results. For example, let's say I have this recommendation, this enhancement that say, recommending the most similar scientific name based on the World Register of Marine Species, the worms. So I could implement this requirement using this specification, this method, that say that I will use the Levenstein distance as similarity metric to select the most similar scientific name in the worms database. Okay. If I use this specification for this recommendation, I would have for this record, let's say, that have the scientific name Serianthus virilis, Serianthus viridis, okay, because there is only one letter, only one character different, so it's very similar considering the Levenstein distance. But if I have a different method, instead to use Levenstein, I would use using Soundex algorithm. The result would be different. Instead Serianthus viridis, I would have Serianthus virili, because the criterion used as similarity, the similarity criterion is different. Okay, so I would have a different result depending on my specification, my method. So it's very important to describe in the data quality report what method was used to make this recommendation, for example, or to make a measure or to make a validation. And the mechanism basically is the tool, the software, the thing that will generate the data quality report that implement this a specific method. Okay, it could be, for example, Atlas of Living Australia or Curator. So it is the tool that generates the assertion, generated the report. This is also important because depending the tool that implement the same method, but because a bug or some internal things, the result may be different from one tool to another. And the last part is the data quality report. Data quality report represent the status of quality of a specific data. It could be a record, a single record, or an entire data set. How good is the quality of this record of this data set? And of course, this status is based on the data quality profile. So it will give us a set of measures of quality based on the data quality measurement policy of a data quality profile. It will give a set of validations based on the validation policy. And it will give some recommendations or improvements based on the improvement policy of the data quality profile. Okay. So let's see an example. Let's say we have this data is a record and have this decimal latitude, decimal longitude, there is a scientific name and a country code. And in my policy, measurement policy, I have this this measure, the consistency of coordinates of single record. This is the dimension that I want to measure. And the measurement of this dimension is made based on the coordinates distance from the species range map, okay? So as smaller this distance, better is the consistency of the record. And how this, and the measure for this record is more than 2,000 kilometers. Okay, so it is not a good consistent. This record is not consistent. And this value was generated using this method, this specification. It calculates the distance to the closest point of the border of the species range map of UCN in kilometers using a CARTO-DB function. Here are the reference for this specification. And it considers 0 if the coordinates fall inside the range map, okay? And this value was obtained using these two mechanisms, Curator and VertNet, Geospatial Quality API, okay? So here is the assertion of a measure based on my data quality profile. But this value is good enough. If we see in the validation policy, we have a criterion that say coordinate distance from the species range map must be lower than 10 kilometers. And so in this case, this data is not compliant to this requirement, to this criterion, right? Because it's more of 10 kilometers. But how can we improve this? Well, we have our recommendation here that's a recommendation of negated latitude. And it is recommending that latitude should be negated. And the specification used to make this recommendation say, recommend a negated latitude when this action results in an improvement of coordinate consistent. So I test if negating latitude will improve my consistent. So doing this, based on this, there is this recommendation. Let's say I accept this recommendation. I change my latitude. If I do this and make the measurement again, if I measure and validate and again, I will have a different value here for consistency. Now my consistency is 0. So these coordinates fall inside the range map of this species. And now this record is compliant to this criterion. Okay, so now this record is okay to use in the context of this data quality profile. So basically this framework and all the specific concepts and formalization, mathematical formalization, basically it just try to serve as a common background to help to describe data quality needs in a common way, okay, in a formal way, describe data quality solutions to meet these data quality needs, and describe how can I communicate, how can I represent the status of data quality based on these data quality needs and data quality solution, okay. I think with this conceptual framework, we can help, we can support the biodiversity informatics to make this assessment and management in a more common way, integrating those data. Actually, this serves as a common ground for re-implementing some solutions based on this common ground. Here is a scenario that this conceptual framework may help in the future. Let's say we have an institution and this institution has a requirement. Let's say I want to validate a taxon name. Okay, this institution will implement a tool to meet this requirement. So he implements the tool X, and this tool X will generate results. Okay, it will validate the scientific names. But let's say in another place, another institution have the same requirement. He also wants to validate scientific name. And this other institution implements another tool, a different tool, tool X, tool Y, and this tool will generate other type of results validating the taxon name. I can see two problems here. First is the duplication of effort. For the same need, for the same requirements, I implemented the two different tools, two different solutions. And the other problem is that maybe the results here maybe is not compatible. Okay, this is an interoperability problem. So based on this common ground, this conceptual framework, we could implement some tools that serve as a backbone, fitness for use backbone, where we can map all of the requirements that exist, map all the tools and methods used to solve those problems, and also mapping all the results generated in a common way. Okay. So, for example, let's say we have another institution, a third institution that have the same need, requirement A. This institution doesn't need to implement a new tool. It can carry in this backbone, and this backbone will say, okay, you can use the tool Y or tool X to solve this problem. You don't have to implement another tool. Okay, so this is a way that this conceptual framework can advance in the future. So thank you very much. I invite you to go to the GitHub of TDWG, where we have the interest group on biodiversity data quality in this link. And I invite you to follow there and contribute with this group, with your challenges, with your context. How can you and see what is happening concerning data quality in this group. So thank you very much.
Okay. Alan, thank you very much. I'm going to kill your microphone while I'm talking, and then I'll turn it back on. Thank you. That was a neat perspective on data quality. Everybody who's watching, please do send your questions as soon as you can to this email or this Twitter account, and we will try to get them answered, but only if you send your questions soon. Alan, I'm intrigued with what you're doing, and I'm interested about how you would see the relationship between data quality and fitness for use and improving the data store that we have now. So let's imagine that I put you in charge of, of biodiversity data at the level of the whole world. Are there particular dimensions of the data? You mentioned taxonomy and georeferencing and time. Are there particular dimensions that you would prioritize, and why? That to me would be very interesting.
Just a minute.
No rush. Take your time.
Well, I would say, for example, if we take GIF as example, let me take this. Okay. I think these dimensions is a good set of dimensions that we're gonna use for every kind of information element, okay? And if you are talking about occurrence data, I would apply these dimensions in basically latitude and longitude, the coordinates, okay? A scientific name or a taxon name, and in the date, the event date. So for these three information elements, all of them would need completeness. Okay, they must be complete for use for most purpose. And the consistency, it will depend on, for example, consistency of coordinates. I could consider the consistency of coordinates according to the related country. This coordinate falls inside the country of this record. This is one way to measure the consistency of coordinate. But I could consider, as the other example, if this coordinate fall inside the range map of the species. Okay, so we can think in a lot of way to measure each of these dimensions. That's why we don't have a set of this is the way that you have to measure data quality. This is the way that you have to deal with data quality. Because there are a lot of different ways to think about this, and depending of the context, you can, something makes sense and other thing doesn't make sense. So, yeah. Okay, I don't know if I answer your question.
No, that's fine. No, that's fine. Sorry, again, I'm going to mute your microphone just for a second. Okay, I'm just very interested in kind of the prioritization. I agree with you. You know, the consistency of the coordinates and those three dimensions. Recently, I've been playing a bit with which of those three dimensions, time, place, and taxon, is representing the biggest gap or the biggest failing in our data store. But here I've got another question from you. This is from Uzma Ashraf, who's a doctoral student in Pakistan. She asks, my question is which tools are generally used to find data quality of GBIF data or occurrence data for ecological niche modeling? So she's looking for specific recommendations of tools.
Mm-hmm. Well, we have ACA Curator. Let me show this one, FP ACA Curator. This actually, I think this is the mechanism that, the only mechanism that it has already used this conceptual framework in the background, and this is a very good and customizable tool for creating data quality mechanisms. Okay, I recommend this tool. Another one that I like to use is the Atlas of Living Australia Sandbox, where you can insert your data set, and there's a lot of checks, a lot of criterions, validations that the data set, the sandbox will perform. I think this tool is very interesting tools for those purposes.
Okay. One of my students here was asking, do you have a GitHub site where you make available your tools?
No. Yeah, I can't. You're asking for these specific tools or other general tools?
Yeah, those and perhaps more generally.
Okay. These two I don't remember, but there is a GitHub for them. I can pass later the specific link. But also we have in our interest group a table, a spreadsheet with a list of tools that you can use. Also, this Atlas of Universal Sandbox and the curator is there in this list. I don't have the link of this spreadsheet too, but you can find this spreadsheet in this link of the GitHub. So in this GitHub, you will find task group 2, and there you will find a list of tools.
Wonderful, thank you. Well, I'm not seeing more questions come in, and that's kind of a failing of this medium. The questions will come in on a slightly longer time scale.
Mm-hmm.
So I think we may be at the end of immediate questions, but what you'll see is that a lot of questions will come in later, either to the YouTube site or to the email address or the Twitter account. And so I'll pass those on to you so that people can get access to your thinking about this.
Okay.
But thanks a million, Alan. That was a very interesting perspective. I'm finishing up a paper right now, and as you were talking, I made a note to cite your paper because it's quite relevant to what I've been working on. So thank you very much, and thanks Antonio for also adding to this and adding the longer term perspective. And to the broader set of people out there, we will restart the more regular seminars in coming weeks as the niche modeling course wraps up.
May I just say something, Tom? You may have known that there was maybe 2 years ago or 1.5 years ago, there was a work group that GBIF has convened to work on defining like a profile for data quality on niche modeling, on species distribution modeling, and Jorge was the leader of that group. So one of the ideas at that time, we were working in parallel with that GBIF group. We knew it was going on. There was a second work group on agrobiodiversity with the same idea, define what are the needs in terms of data and data quality for agrobiodiversity. And since GBIF was part of our partners, that paper has at least 2 people from GBIF, Dimitri and Tim, yeah. So the idea would be to have the input from those 2 groups, agrobiodiversity and species distribution modeling, as seeds for us to work on formal profiles using Alan's and the interest group idea on this framework. So it would be wonderful if maybe you and your group, we might interact to make that idea move forward, because I guess it came to a standstill. So
that's a very good idea. I know I was part of the group that fleshed out the niche modeling side. First meeting in New York, and I remember that was feeding into the meeting in Sao Paulo. And that paper, a paper coming out of that, is probably quite close to submission now. I think a final draft was circulated this week. But yeah, I mean, I think the idea of creating kind of profiles of needs for different dimensions of biodiversity informatics community, that would be fabulous.
Yeah.
It would allow a flexible definition of data quality. You know, essentially, we can imagine fit for use for one thing, not fit for use for another thing, or you know, not fit for use but could be made fit for use.
Yeah.
You know, with, I don't know, georeferencing or whatever.
Yeah, yeah. And having those profiles might even be something that publishers are interested in. We talked with people from Pensoft, for instance. That might be something to add in a materials and methods of research, of articles, so you can see that it's part of the, the materials and methods. So what do you use? So instead of having people having to go through all the process of analyzing the data set that someone has submitted, and then what is the data set that at the end was effectively used. So you have the profile to set to make that clear. So I'm using this profile for species distribution modeling that was published by these guys, and so this is the criteria that we use. These are the dimensions, and so on.
Yeah, you can imagine kind of a next generation biodiversity data portal where you not only lay out the taxon that you're interested in, but also the use to which you're going to put the data. Yeah. And you could get, you know, here's the ready for use data, although of course I would encourage the user to check anyway, as anybody would. Here are the ready to use data, and then here's the rest of the data with a list of the sorts of problems that they have. You know, maybe the time information is inconsistent.
Yeah, yeah, yeah.
So, yeah, wonderful.
That's
I'd like to talk more about that.
Yeah, that's the wish list of Gibi, for instance.
Yes, exactly.
So thank you.
Thank you both, and I look forward to seeing you sometime soon.
Sure. See you at least in February.
Okay, sounds good. Ciao, ciao.
Ciao.
Thank you.